the jet parameters. They ask you to find the jet parameters of this network. We have a two-port network here. This is a port 1, I can say. This I can call it as V1. The second port, this voltage is a V2. The port 1 current, I can call it as I1, and this current is I2, and both currents are entering into the network. Now this current is I1, so this current is also I1, and this current is I2. Then what this current is now here? I1 plus I2. This current is I1 plus I2. Then how much this current is a I1, and how much this current is a I2. Law of conservation of charges. Whatever the current is entering, the same current has to return. So from this I can apply the KVL in this loop, and KVL in this loop I can apply. Tell me KVL in this first loop now. What we can say here? V1 equal to, what I can say here? ZA into I1 plus what? ZB into I1 plus I2. So from this, what I can say? V1, which is given as, what I can write now here? ZA plus ZB into I1 plus ZB into I2. And see in this loop now here, V2 is given as what in the second loop? ZC into I2 plus ZB into I1 plus I2, some of the two currents now. So from this, what I can say? V2 equal to, this is ZB into I1 plus what? ZB plus ZC into I2, I can say. Now, as we know the standard jet parameter equations, we know V1 is equal to Z11 I1 plus Z12 I2. I can compare these two equations now here. The coefficient of I1 coefficient is a Z11 and the I2 coefficient is a Z12. So from this I can write the Z11. Tell me Z11 now here, which is equal to ZA plus ZB. Next Z12, which is equal to what? ZB. And we know the another equation of the jet parameters is what? V2 is equal to Z21 I1 plus Z22 I2, isn't it? Now I can compare these two equations now here. The coefficient of I1 is a ZB. Coefficient of I1 is here, it is a Z21. So from this I can write Z21, which is equal to what? ZB, and Z22, which is equal to what? ZB plus ZC. Right, so these are the jet parameters. So finally I can write my jet matrix. I can write the jet matrix now here. I can simply call the jet matrix as like this. Jet matrix Z11. What we got? Z11 is a ZA plus ZB, ZB, Z2 to ZB and ZB plus ZC. Check it. Excuse me. Isn't it? Now, if we see this network, look at this network now here carefully. This network which is given as like this. They given this as a ZA, this is given as a ZB, and this is given as ZC, isn't it? Now you can see here, this is Z11 now. Z11 is what? Sum of these two, isn't it? This is Z22, this is what? Sum of these two. Next, Z12, Z21 is the common element for these two branches, common element or not, isn't it? So now onwards we'll remember this as a shortcut for this thing. Whenever the network shape, you can see the shape, how the shape of the network is a T shape now, the form of a T shape now. Whenever the network is in the form of T shape, so then we can directly find the Z parameters. Z parameters simply we can do like this. But here you need to take care of this thing, one condition here. Here you will see here ZA, what the units are? Ohms. This units are ohms and this units are ohms, means all the units must be impedance, ohms must be. Sometimes to make you confused, they will give this in terms of mhos, 1 by ohm. So whenever there has been given like this, in that case what we need to do here, first we have to convert the admittance or conductance in terms of resistances, impedances, then only you need to apply. So the thing should be, what we have to make it is a, the units must be in what now here? Ohms. Here the units must be ohms. If they given mhos,